My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Sometimes mathematical relationships exist between two values. These relationships are useful and can help us answer many questions. An example of this is buying a candy bar at the store. Suppose your favorite candy bar is 50 cents with tax. 2 candy bars cost $1. 3 candy bars are $1.50. 4 candy bars cost $2. Notice that as one value increases, the other increases. The ratio between the two variables, candy bars to money, is always the same. In this case, each time we increase the number of candy bars by 1, we increase the cost by 50 cents. Decreasing the number of candy bars by 1 decreases the cost by 50 cents. Because of this consistent relationship, the variables number of candy bars and cost are said to vary directly. Direct variation relationships are ones where an increase in one value leads to an increase in the other. On the other hand, when one value decreases, the other value decreases as well. The ratio between the two values is always the same. Direct variation relationships, also known as proportional relationships, occur in many places in the world, and we often need to solve problems involving variables that are proportional. To help us solve problems, we can represent situations with direct variation in a few different ways. One way we can model the previous example is by using a drawing. I will draw a bill and 2 candies to represent the cost of 2 candy bars. Suppose I want to know how many candy bars I could buy with $3. In this situation, I can repeat the drawing representing $1 as many times as necessary. After I create the drawing, I count the values. I drew 3 bills and 6 candy bars. For $3, I can purchase 6 bars. A bar model can also be used to model direct variation. Ariana manages a hotel and conference center. Before this weekend, she must check all the lights in each conference room. Each room has 8 lights. If Ariana checks 12 rooms, how many lights must she check? I will use a rectangle to represent one room. I separate it into 8 sections to represent the 8 lights in each room. Since we want to know the total for 12 rooms, I draw 12 rectangles, each separated into 8 sections. Now we count the sections to find out the number of lights. There are 96 sections, thus Ariana must check 96 lights. A bar model is a less detailed drawing representing the relationship between directly related values. While I could have drawn a rectangle to represent the room and 8 light bulbs inside to represent the lights, it is a bit slower than drawing rectangles. Besides, if you're not great at drawing or you just want an answer, drawing pictures may not be convenient. A table is helpful, especially if we want to investigate the relationship between the values in other ways or we need to know more information. Kaji drives 62 miles per hour. How far does Kaji go at the end of each hour for 3 hours? Since I know how far Kaji drives in 1 hour, I can increase the number of miles by the same amount. Each hour Kaji drives, he drives 62 miles further. From our table, we can see how far Kaji drives after each hour, and that he drives 186 miles in 3 hours. Another way to represent these relationships is with a graph. We can plot the points from the table as coordinates and get this graph. A graph provides a visual representation combining some benefits of diagrams and tables. A graph also provides a quick way to determine if a relationship is related by direct variation. Graphs of proportional relationships share 2 qualities. The graph is always a straight line that passes through the origin. We often use mathematics to help us understand and use relationships between values. We get a ratio when we compare two values that have a consistent relationship. And when the values measure different things, including candies per dollar, light bulbs per room, and miles per hour, we create a rate. Notice that in each of the previous examples, we knew the unit rate. We can multiply the unit rate by the number of times it happened to find a total, represented by the equation y equals kx. The result, y, comes from multiplying the unit rate, k, by the number of times it occurred, x. In this case, we say that y varies directly to x. The variable k is also known as the constant of proportionality. This equation is important in mathematics. It represents all direct variation or proportional relationships. Because the rate of change is consistent in situations involving direct variation, we can use the relationship and the equation to help us solve problems. From the first example, I could buy 2 candy bars for $1. The equation y equals 2x represents the relationship between the number of candy bars I can buy, y, and the dollars I have, x. With this equation, I can now calculate the number of candy bars for any dollar amount. If I want to calculate the number of candy bars I can buy with $25, I substitute 25 for x, then solve the equation. Y equals 2 times 25, or y equals 50. For $25, I can purchase 50 candy bars. What equation represents the number of lights Ariana needs to check if there are 12 lights per room? How many lights would she check if there were 22 rooms? The equation y equals 12x represents this situation, with x being the number of rooms and y being the total number of lights. To calculate the number of lights Ariana must check, substitute 22 for the variable x, then multiply. 12 times 22 is 264. Ariana would need to check 264 lights for 22 rooms. What equation represents the number of miles Kaji can drive if he drives 63 miles per hour? How far does Kaji drive in 9 hours? The equation y equals 63x represents this situation, with x being the number of hours and y being the total number of miles Kaji drives. Substituting 9 for the variable x gives 63 times 9. Kaji drives 567 miles in 9 hours. An equation is an efficient representation of a relationship that allows us to find any combination of values. Each of these is a representation of a directly related relationship. Different representations have different uses, so it is valuable to be able to work with each. Christoph manages a product's social media posts. He says his most recent campaign posts are receiving 7,500 likes per hour. Represent this relationship with a diagram representing the number of likes after 6 hours, a table, and a graph showing the number of likes for the first 6 hours of the campaign, and an equation. Use the equation to determine the number of likes after 24 hours of the campaign. I will use a bar model for the diagram. Each bar represents 7,500 likes. Because I want to know the number of likes after 6 hours, I draw 6 of these bars. I start my table by writing the two variables, hours and likes, at the top. I start at hour 0, where there were no likes yet. I add 1 to the hours column and 7,500 to the likes column. I continue this until the table contains the hours 0 to 6. To create the graph, I use each hour-like combination as an ordered pair. Because we are looking at the change in hours and its effect on the number of likes, I will use the x-axis to represent hours and the y-axis to represent the number of likes. I then plot the points on the graph. For the equation, I start with the generic form y equals kx. The unit rate for this problem is 7,500 likes per hour, so this becomes the constant of proportionality. The equation becomes y equals 7,500x, with y representing the number of likes per hour and x representing the number of hours since the marketing campaign began. Finally, I use the equation to determine the expected number of likes after 24 hours. Substituting 24 in for x, then multiplying gives a result of 180,000. Christoph should expect 180,000 likes after 24 hours of the marketing campaign. In my mathematical world, I have one little problem. I am helping people involved in Georgia's industries. Help me provide accurate information to some of those helping Georgia grow. Rania studies marine life off the coast of Georgia to help the shrimp industry. Today, she is collecting samples of marine life. She collects 12 shrimp of the same size at each spot she must sample. Represent this relationship with a diagram representing the amount of shrimp after 3 stops, a table and a graph showing the number of shrimp for the first 5 collection spots, and an equation. Use the equation to determine the number of shrimp collected after 15 sites. At each collection location, Rania also collects a sample of blue crabs. She decides to collect a sample of 5 crabs at each spot. Write an equation to determine the number of blue crabs collected. Then use the equation to determine the number of crabs Rania will have accumulated after the 18th location. Moran raises blueberries on his family farm because blueberries are one of Georgia's cash crops, with Georgia being one of the top producing states. His workers can collect 1,250 pounds of blueberries per hour. Represent this relationship with a diagram representing the pounds of blueberries picked after 6 hours, a table and a graph showing the number of blueberries harvested for the first 6 hours, and an equation. Use the equation to determine the number of pounds of blueberries collected after 24 hours of picking. Moran also has a large peach tree orchard planted by his grandfather. Moran said that his operation harvests 152 peaches from each tree. Represent this relationship with a table and a graph showing the number of peaches harvested from the first 5 trees. Moran attended an informational session on raising chickens because he heard it has become Georgia's largest industry. He decides to raise chickens, but he wants to start slow and expand. This table represents the number of months and the total number of chickens he plans to have. Is this a direct variation relationship, and how do you know? Take a look and you will see a mathematical world around you, filled with relationships. There are many relationships that you can explore with mathematics, and those which are directly related are everywhere. Directly related values increase or decrease in a relationship to each other, and graphs representing these relationships are straight lines that pass through the origin. Representing relationships between directly related variables can help you solve many problems in the world around you.